So this question, coin change 2, right? So we have an array of coins and we have amount 5. The goal is to figure out how many combinations are there for given the array of coins, so that we can finally have the value 5 in here. So take an example in here. This example, we have 4 different combinations possible. So the one thing we notice is we cannot have duplicates in here. So for example, we cannot pick a 2 again, and then pick 1. And then we also pick 2, pick 1, and then pick 2 in here. Because those are the same combination. So we only have to count 1 rather than twice. So by looking at this example, this could inspire us by saying that we do the recursion with a certain order. For example, we're gonna try to fit the amount by using the rightmost coin, which is 5. Okay, so luckily, like, we just get the amount equals to the final amount in here. So now we're gonna take out this 5, and we're gonna only use 1 and 2, okay, without using the 5, right? Okay, because we tried 5 already. So we're gonna 1 and 2, and then we have, okay, so we're gonna try to still do the same thing, try to fit the amount by using as many as 2s as possible. Okay, we try to have the first 2, the second 2, and then we cannot have a 2 anymore, right? And then that's where we're gonna further shrinking down the number of choices, only have 1 available, so we're gonna pick a 1 in here, and then we finally have number 5. And then now we're gonna look back, and then we're gonna only have 1 2 in here, and then we have 1, and only a choice is a coin is 1 now, right? We're gonna have 3 1s. So notice here, when we shrinking down the number of choices, we're never gonna go back to 2 anymore, right? Because this will result in duplicates if we do that. So I have 2, and then we're gonna have 1 1 1, and then finally we're gonna have 0 2. So we're gonna take out these 2, and then because the fact that we shrinking it to only 1, we have all the 1s in here. All right. So this is our intuition of how to solve the problem. Now let's take a look at the code. So we have a helper in here, the same parameter list, except we have an end in here, right? So this end denotes the index that is available for us for the coin array. So for example, at the beginning, the end will be 2, which is pointing to 5. And then as the iteration goes along, we're gonna shrink this available coin array to 2 and then to 1. So in here, this is the important part where we iterate through, right? We iterate through a counter. What is a counter? Counter is the number that is available, the maximum number that is available to fit the current coin to the amount. So for example, in here, we can only fit 2 2s, right? The third one will result in a negative number, so that the maximum, the count will be 2 in this case. Okay, so for every count, right, starting from the maximum until 0, we don't have the current coin, we don't pick the current coin anymore. So we're gonna have a remainder in here. So amount minus the coin, multiply the amount of coins we're gonna choose. And for the remainder of coins, what do? We're gonna start shrinking the available coins, right? We're gonna do an n minus 1. That's where we do the recursion again. Okay, so once we've done that, if like somehow we found a solution, meaning that the amount is 0, right? We return 1. If we found a solution, then we're gonna move plus 1 to the result, and we go back to the iteration where we're gonna take out 1 of the current coin. So in this case, we're going to take out the 2 in here, and we have a larger amount, we have a larger remain, and then it goes to another iteration where we continue to shrink the available coins to 1, and then we figure out whether we have another solution, right? Until there's no more, we don't pick any of the current coin, right? And we shrink it down to all the to the next iteration, and we keep going and we keep doing that. Yep. So this will give us a correct result, but keep in mind this is not going to be passing the online judge, because this is very time consuming, right? So as long as we have this, it's very easy to make it pass. We just need a memo for this, and like we cache the results, like we can have a 2D array to cache the results. So because we have the end, right, which is index we need to record, and then we also need to record the amount. That's the only 2 things. So as long as we have the cache, we're gonna say in here, like if cache hit the cache, then we return the result, and then otherwise we're gonna do the calculation until the end. We're gonna put the cache with the value of RET in here, and then we are done. Right.